So this why I'm talking about this defect, because it is because of this defect the prime component, as I told, is being compromised. The rail the component, we are not getting the 130 meter rails, and because of this the process delays occurs, and the welding joint per panel is increased. So the modification we have done is to change in the design of the guides. First, this is the guide. It is shown in the figure, and this is basically the original portion of the design, and the portion which is being susceptible for rubbing of the guides, sticking of the metal. We have changed that portion of the guides. And second modification we have done is we have done cooling arrangement in the guide system. We have incorporated air knife also, which flush out the loose the particle which take the form of the leaf is flushed out. And finally, we have optimized the guide level to reduce the sticking of the metals on the guides. That was the previous one. So this kind of simple arrange has resulted in a very good result. This is a cooling arrangement, and this kind of thing is a air knife we have done. And this part is portion where the most of the metal was getting sticking. We have changed this part of guide design according to that. Thank you. Thank you.
Thank you so much, sir, for sharing your learnings. Now the forum is open for Q.
Uh, Yeah, one is the cooling arrangement, one is the air knife arrangement. So any loose
Any
particle, yeah, yeah,
particles?
yeah.
So it is done during rolling or after rolling
It's
you
during rolling only, sir.
during rolling you
During rolling, yes,
continuously.
yes.
So it doesn't impact cooling rates or
No, no,
anything.
not sir. Okay. Thank you.
Thank you.
Yeah, this is the crop saw. Metallic, metallic.
Surprise, any grades,
Oh, it's a high speed steel.
high speed. Okay.
Thank you.
Thank you so much, sir. Is it fine, sir? Thank you so much, sir. May I proceed further, sir? Done. Okay, sir. Now I invite Mr. Abhishek Tomar from SAIL ISP to please come forward and present on manifold flow optimization and slater guide lubrication upgrade.
Good evening, all of you. My name is Abhishek Kumar. I am working at Tool Turning Shop at SAIL ISP Burnpur. So, this is the actually project we took after introduction of HSS role. We were facing some challenges in cooling and lubrication of the guides. So, this is the brief process we are having at ISP. So I'm not going into that. I'm just telling like there are three mills, WRM, bar mill, and USM. USM is having capacity of around 0.75 million ton, bar mill is 0.9 million ton, and WRM is 0.5 million ton. Next slide, please. So basically, what happened? We went from cast iron rolls to HSS roll, and after HSS roll, the production is also increased significantly, and there were many issues of using cast iron rolls. So after HSS implementation, as we all know, it is very having very high hardness. So cooling efficiency was not that much because the system was designed for the cast iron rolls. And also guide has to work for more tonnage. So that's why we were having premature failure of the guides, especially streeter guide and the entry guide of the stand 14. Next slide, please. So coming to like I have tell about the HSS role because after introduction of this role, our bar mill is working very effectively. So since HSS role, we are getting past tonnage of around 2500. I have mentioned 2010 because it is given by the this roll supplier, but we are getting around 2500 to 3000 ton per pass. And the thing is dimensional accuracy plus scrap is overall sectional stability has increased a lot. So next slide. But there were these kind of failure. If you can see, tip was cracking like this, and collar was breaking like this, and this is the uh, uh, failure of the roll. It cracked from middle. So we asked our team to monitor the temperature of the HSS roll, and we were getting around 50 to 55 degrees centigrade at the pass. So it means was not that effective. And this is the photo of sliter guide. We are not having power sliter, we are having simple sliter. So here also the bearing which used to come from the mill was like dry, having the black grease. So the grease, the lubrication was not proper. So we did root cause analysis for this, and we found that the existing water manifold, which was supplying water to the pass, was not having nozzles, adequate number of nozzles for a uniform cooling. So, and the other thing is, online supplying of grease was only 3 cc per hour. So we found like it is insufficient. Next slide, please. So you can see this one was the old manifold, like which we were using. So you can see here only one nozzle is giving, and here also one nozzle is giving. So we in-house added four nozzles, two here and two here in this side, and then started measuring temperature. So you can see we just added the extra nozzles. We kept the orientation of the nozzle as the old manifold, and the arc is also same. We just added the water nozzle. So you can see the roll temperature significantly dropped from 50 to 55 degree to 42 to 46 degree. And water pressure is same because we were not able to increase the water pressure of the line. Flow is also this. So overall, we achieved around 16 percentage of reduction, and the failure of the roll is also reduced. Next slide, please. So for sliter guide lubrication, uh, as we cannot increase the online greasing from 3 cc to the higher side, we put it we have done offline greasing system. So here we have put one changeover valve. Currently, it is operated manually. A person is going and operating it, and we are supplying the grease directly to the sliter guide and the entry guide of this. Sliter is exit guide, and this is entry guide. So we are directly giving it grease to these guide, and we are supplying it like 6 cc per hour. So now we are getting proper lubrication of these guide, and failure of these guys has also reduced a lot. Means we are not getting that much failure. So you can see 6 hour per cc, 6 cc per hour, and the proper penetration and coverage of the lubrication achieved, and bearing life is also increased. Next slide. Thank you.
Thank you so much, sir. Now the forum is open for Q&A. Any questions, sir?
What's your billing number? Ball bearing, right?
Deep flat, flat type
How often you are changing now after modification?
nozzle
I mean this guide roller
guide roller.
life.
Bearing life depends on three things like stock first of all and cleaning, and the other thing is lubrication. So we have done a lot of work in cleaning also. Whenever we are sending the guide, we are checking it with the water, because earlier the line which is in guide body used to block. So every time whenever guide is there, we are checking it thoroughly, then sending it. So we are nowadays we are not getting that much failure as
This is water cooled, right?
water cooled. Roll is water cooled.
So what about that nozzle from where? From which party you are procuring?
Lackler.
Lechler only. Okay.
Actually, they are also coming. They will check the water system thoroughly now.
Okay. What is the pressure you are maintaining?
4 to 5 bar.
45 bar. Okay.
Thank you so much, sir, for sharing your learnings. Next, I invite Mr. Shalanes from JSW Vijayanagar to present on enhancement of turn down insert line for quality improvement in wide rod mill.
Good evening. Myself Sharnesh. I am from LP Mills JSW. So my project is enhancement of tendon inserts life for quality improvement. So this is the process flow of Vijayanagar steel plant, where from iron ore to finished product. We are from long product mills. We are long product mills of we have bar rod mill and wire rod mill, which have two sections again, bar rod mill 1 and 2. So this is a simple process flow of the wire rod mill 2. Here we use raw material as a billet. The billet is received from the SMS and has been stocked in the billet ad as per the marketing requirement, depending upon the size and the grade. The billet is being charged into furnace. The furnace here is an reheating furnace, which is a working beam type, and we reheat it up to 1050 degrees Celsius. Then the billet is passed it into the descaler to remove the scales which is formed due to oxidation. Then the billet is passed through the IRT to breakdown mill, which is BDM. Here the billet is roughly transformed from billet to the round cross section. Here in WRM2 we have two lines with two strands. One is line 1 and the line 2. Both are same and identical. The operations also same in both lines. So alternatively billet passes in each line. So I can explain the one line. The after BDM, the material passes to roughing mill through IRT2. The reduction and increase in size and producing the required size in these stages: the roughing mill, intermediate mill, pre-finishing mill, no twist mill, reducing and sizing mill, where the finished size will be achieved here. Then it goes to LHPR, turn down, and laying head pipe. Here in laying head pipe, we can see there is a transformation from the horizontal straight form to the circular form through turn down. So then after the laying at pipe, the material forms rings and passes to cell mode. Here we can see the improvement in the mechanical properties, then the reform. pellet area, down ender, compactor, and finishing yard where we stock our coils. Depending upon the customer requirement, we pack the coils and we transport it to two modes, rail mode and road mode. So this is wire rod mill 2, which is a design capacity of 1.2 million ton, and we produce the sizes varies from 5.5 to 25 mm with all the low carbon, medium carbon, and high carbon, and also electrode grade uh, products. Then we use here billet as a raw material, 12-meter length with 165 cross section. Here I can see that billet, which is after discharging, it is it can be rolled and also the non-rolled. If it is non-rolled, it is cobble, misroll, and auto. If it is rolled, then it is prime coil and defective coil. If it is prime coil, then it directly goes to customer. Our pain area is our defective coil. Later on slides I will discuss. These are our major customers and the wire rod applications, which is used in electrode, wire rope, fasteners, piston rods, tire cord gates, steel decorations, wire mesh, and many more automotive industries. So our pain area is in the defective coils. So some of the defectives in the wire rod coils are the laying variations where the entanglements, ring distributions are not formed. Then the line marks in the rings, the dent marks in the rings, which is formed because of the process. Anyhow, the pain is pain. Defective coils are not we cannot send it to customer, so we need to reduce it. This is very impacting and to our business. So through through analysis and with the cause and effect diagram, we were able to find out the what are the possible causes for getting this defective in the coils. So some of the points we have noted through the fishbone diagram, and we are going to forward for the solutions. So with the fishbone diagram, we got some idea, and we have validated through the Pareto analysis, and where we have found that the turn down groove wear out rate is more, and for the which is contributing more for defective coils. So now we got the turn down. Turn down is the simple equipment which is installed in between the LHPR and the laying head pipe. So here the main angle, pass line angle has been will be changed here from the pass line from horizontal it will gets to the laying head pipe. The metal from straight will form to the circular form. So there is more chances of groove and wear out in the turn downs. We can see after that the ring formation happens in the shell mount. So these are the parts of the tendon assembly. We have four parts, we have four plates: left side plate, right side plate, upper plate, bottom plate. Where the upper plate is a tungsten carbide plate, where our path is flown in that plate. So as I said in earlier, the angle is changed, the pass is changed into from the straight to circular. So there is a sudden change in the angle. That is why we can see that the major wear out can occur here in this area. So that is why we can see the groove wear outs are more. So whenever we insert inserts with a gap of 10.5 11 mm, within no time it gets worn out to 32.5 mm increase of the uh, groove happens. So these are the impacts of the problem and our objectives, how to overcome this. So the impacts of the problem are quality, which where the laying variation occurs, the consumption, frequent change in laying at pipes and turnedowns, production due to cobble, we are halting the mill, which again impacts the production, and the delays, the frequent mill checking and change of inserts, so making our production stops. So the same impacts again our objectives to improve the quality, to improve the consumptions, to reduce the consumption, to reduce the cobbles, and reduce the mill checkings. So goal is to deliver quality products to the customer. So we have developed in the development one the side plate. So our tungsten carbide plate is getting weared out. So we have given 3 ports in the side plate for water to prevent the friction in between the point and the coil, and the reduce the eating of the plate, where we have not seen such a significant result in this development. So we again went to development 2. We have used pipe. This pipe was 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 okay, but the scales have been formed in the pipe. Because of this, the cobbles was more, and the pipe should change in every mill stoppages or every mill checking. So we thought this is also not a significant result. So we again went into development 3, where that tungsten carbide plate itself made modified. Here we have done 2 modifications. One is change in design, and the implementation of water port in the bottom plate, so that the water directly injects the water to the tungsten carbide plate, so that it prevents the heat and also reduces the wear out ratio. And the change in design, the change in design here, due to change in design, our consumption has been reduced. The same tungsten carbide plate has been used for three passes. So here is the 3 positions which we have used. One is the right side plate is used, and the left side will support part is removed. The upper carbon tungsten carbide plate is kept for in the right corner. Then the center one will be the center pass, and the left corner will be used as a third pass. Here we have seen the improvement in the tungsten carbide, and also reduction in the consumption. This is the development through water. The water here we have given in the bottom plate, and we have made a grooves to flow the water directly. These grooves, the water flows from the grooves and injects into the upper plate. Yeah. So this is the achievement, that is before and after. Before we have getting around 12,000 tons. Now it is double, like with the 3 positions, the same delivery. So the journey of the turnaround sets some of the benefits. Thank you. Thank
Thank you so much, sir, for sharing your learnings. Now I invite Mr. B.K. Devangan from SAIL ISP to present on development of LRPC grade from ISP.
Good afternoon, everyone. My name is Anirudh Bishwas. Uh, our topic is that the development of LRPC grade in wire rod mill in SAIL ISP. At the onset, we will go through the capacity and the process flow of the mill. The installed capacity is zero point 0.5 MTPA, and the technology supplier is Danieli. This is the process flow diagram of WRM in ISP. We have a 150 ton per hour reheat furnace with a working beam. It is a side charging, side discharging type reheat furnace. Uh, 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 the billet enters at the descaler, and the roller table is there with the heat retaining hoods. After that, we have mill entry pinch roll and snap shear also. After that, we have 4 strand roughing mill, followed by 6 strands intermediate mill and 6 strands pre-finishing mill. There are two shears, shear 1 and shear 2, crop and cobble shears. After pre-finishing mill, we have the fast finishing block 1. It is of 2 pass, and after that we have fast finishing block 2 of 8 pass. Then we have water boxes and intermediate pinch rolls. After that we have a twin module block. It is 2 blocks with 2 passes each. Then we have a water box 7 and finally laying head. After laying head, we have a 113-meter cooling conveyor with control cloning. We have 20 ventilation fans and 31 hoods for that. After the conveyor, we go to the reforming area and the easy down area. That is followed by the C hook area and compactor. Finally, we go to the customer. These are the basic features of the mill. We have a single strand continuous. The mill is at plus 5 meter. At 0 meter, we have the cellar. The capacity of the mill is 5 lakh tons per year. The wire rod sizes we roll is from 5.5 to 22 millimeter. And the rebar, originally it was designed for 6 only. We have developed 8 and 10 rebar afterwards. The reheating furnace type, as already told, is 150 ton per hour. Input billet size is 150 by 150, 12-meter long. Maximum speed of the mill is at the laying head is 115 meter per second. Next. Uh, the Some technological features is the walking beam type reheat furnace. We have the online descaler unit. Pressure is at around 200 to 20 bars. We have a combination of 16 horizontal and vertical passes. So we are doing no twist rolling. And we have 113-meter long cooling conveyor and automated compacting and strapping machine. We have best monthly highest of 47,000 ton in July 2025. For the last 2 months, we have achieved the annual business plan. That is for December 25 and January 26. We have ourselves developed 5 new sections, that is 6.5, 9, 11, 13, 13.5 and 18 And we have gone for the bearing management system by Danieli. So by that we have improved the guide life from 100 billets to 400 billets. From now onwards, Balkrishna will take over.
Now, as per the market demand, we have to produce LRPC. So it is worth uh, so for introduction, what is LRPC? LRPC is a combination of two words, LR and PC. PC is pre-stress, means we intentionally develop some internal stresses in the concrete through some mechanical system, so that when it will come into service and when it will be loaded, the same stress will counteract the load, and the life of the concrete will improve. And what is relaxation? When the concrete or the structure comes into the load, and then the that stresses we intentionally developed will be gradually relaxed. So this is called relaxation. And now the what is low relaxation and pre-stress means uh, we need a concrete in which the relaxation loss will be less. Effect of this benefit of what this will happen, that our durability and the performance of the steel will improve. If the relaxation will be high, the premature failure of the structure will be more. And why LRPC? What are the benefits of this? Means it will reduce 10% cost in steel and concrete consumption. Second is the 15% saving in construction cost, and will be less use of anchors, ducts, and wedges. Low relaxation, so there will be less tension in the bridge, and we will require less supports for the bridges. There will be high corrosion resistance, and higher fatigue. We do not need immediate support for that, and minimum impact to the immune. So how we will produce for that? So after some analysis, we got some chemistry, and these are these chemistry parameters, that carbon 0.8 to 0.83, magnesium 0.7 to 0.77, silicon will be 0.25 to 0.3, and sulfur will be 0.05, and this so on. And the parameters what we kept in our mill was furnace exit temperature. What we maintained is 1125 to 1135 degrees, and the last finishing temperature what we are getting at laying end temperature was 840 and 850 degrees Celsius, and in between that we have 8 pass and TMB. So TMB temperature was 870 degrees Celsius and 890, means 870 to 890 degrees Celsius. Cooling of the coil, we kept our cooling conveyor speed from 0.6 to 0.7, and mill speed what we kept was 11.38 to 31.38 to 31.5 around. And for cooling in water box, we kept water box pressure to 4 to 5 bar, and water flow cumulative will be around 300 to 350 meter cube. And in experiment, we kept 4 conditions. Means we took trial in 4 different conditions. We have cooling conveyor fans, 20 fans, and we kept all the fans open for first condition, and in cooling conveyor speed we kept 0.6. For that we got UTS and RA percentage. In second condition what we kept 5 fan 9 stop. So their phase transformation occurs, so we kept that fan 9 stop, and we kept cooling conveyor speed same. For the same slightly get percentage slightly. In condition 3, we kept again all things 100%, and the cooling conveyor speed will be 0.7. And last again we fan 9 kept stop, and cooling conveyor speed 0.7. So these are the different readings what we got, and these are the some online readings what we got, and after the aging we are getting some good results. So as per the requirement we are getting all the good results, and in these experiments we got that with the cooling conveyor speed increasing we are getting better ARA. So during the production, in some cases we also increase 0.8 to 0.9 mm also. These are the some LRPC is giving these choices and advantages for the others. So these are the demand of the market, and we successfully achieve production of that. Thank you. Yes, sir. Aging, sir, 150. This is artificial testing. 150 degrees Celsius, one for 1 hour. No, sir. Aging testing. Actually, we are getting after after 1 week we are getting almost same rate. This is not a trend. It is sample test.
No, that's why I'm asking the diffusion of the hydrogen. So that's why you are keeping the coil for 20 of on no, in this for the oven you are keeping the one sample, does it? But normally all the coils you are keeping as a 15 to 20 days for the aging. You find any other solution for diffusion of the hydrogen other than that? Without aging, or you are think of any continuous type of the oven or something like that? The same type the process we are also following that this one we are also keeping the same 20 to 20, 15 to 20 days for the aging, and the same what you are talking about that oven for the 150-degree. Same we are thinking of it that, but we are thinking this is a continuous so that this aging time will be reduced, drastically reduced if we have a continuous oven. But in the coil form, it become a very difficult to put the coil. Either you have to put the oven on the slat conveyors or something like that. Okay. Yeah. Okay. Thank you. I think. Yeah.
What is the wire rod size that you are producing?
11 mm.
11 mm at 31 meters per second. So what is the maximum that you are producing for LRPC grade?
For 11.
No, no, maximum wire rod size for LRPC grade. 12 is the maximum.
No, LRPC only 11. 12 is
So what is this? You are maintaining laying temperature around 840 to 850-degree.
yes.
Is there any specific reason for that? Why not 900-degree?
But RA will reduce. RA and UTS will
But
affected.
if you lay at lower temperatures, then your UTS get affected, right? So because you're cooling at 36 means 0.6 meters per second is your conveyor speed.
Yes.
That comes around 36 meters per minute. This is a conveyor speed, and at such conveyor speed is also less, and your layer temperature is also lower set than how. So, so your not, but that is not the case, now, because at higher temperature laying and at faster rate of cooling, you will get the UTS on the higher side. If you're laying at lower temperature and your conveyor speed is also lower side, then UTS achieving of 1200 above is very difficult. Yeah. There is a GBC formation in that. Now the carbide cementate also forms in that with slow cooling rates. Okay, we'll shall discuss on that.
Thank you so much, sir. We have almost come to a conclusion. The last presenter of LP2 session is Mr. R.L. Patro and Mr. T.K. Paul from SAIL ASP. So please come forward for the presentation on control of tongue marks using modified tongue pin. Please come forward, sir.
I'm from Steel plant. These are the facilities we have. Sorting machine, so those are the products we produced. Next. Here, these are the mill defects where we have worked. Next slide. Next. We, ha- we have worked in mechanical mark area. We we have different type of inputs, ingots and blooms. Ingots are bigger in size, so when we use these types of tongs to discharge materials, the tongs be nullified after rolling due to hard amount of work. But when we use input like DSP blooms 240 by 350 and Eli blooms like 300 by 335, the mechanical mark occurred during discharging of materials does not gone due to working on that bloom is very minimum to 300 by 335 to 125 BRC or 100 round, etc. So to reduce this type of defects, we changed this type of tongue spins to that type of tongue spin. So after that, we have minimized the tongues mark. Next slide. This is the graph. Uh, overall, overall total rejection. That is the amount of rejection that is due to tongues mark. After modifying the tongue spin, the tongues defect of tongues mark get reduced last January 0.03% only. ठीक है, nothing to. Thank you, sir. So this is one chart. This is one table of fuel consumption. Our fuel consumption is very high. We are trying but not able to reduce it. We have tried a lot. If you have any suggestion to reduce the fuel consumption, you can say. We are not using oil at all right now. Our LNG that is 50% or 37%. CO motamoti 50%. Hot charging is also we have tried, but we cannot charge we cannot hot charge as we want due to all the produced by the SMS. We cannot roll at once. To roll that rate, we need to change the roles. Thank you, sir.
Thank you, sir. So this is the last for Q&A session. So please.
You are soaking the blooms or finished product or the raw material? Input material.
Taking the input material and soak for for bloom we are soaking it for 3 to 4 hours, and for ingots we 6 to 8 hours normally.
Okay.
6 to 8 hours normally soaking. Soaking means what was your rolling temperature is rolling 1280 degrees centigrade. We kept it 1280 for 8 hours.
8 hours.
We have tried so many times. No way we have found to reduce the fuel consumption. We are producing 300 RCS WAP output 300 RCS or 240 RCS, 140 across plat for defense, 125 BRC, different size of rounds, 210 round to 75 round, and 75 rounds sometimes occur. These are the points. Input, input 605 ingot maximum, 500 ingot lowest ingot for blooms, 240 by 350 blooms from DSP, and from Villa we get 300 by 335. Only in blooms, transmass occurs due to working is very low. From ingots it's gone.
Okay, sir.
Thank you so much, sir. So let us clap and Before concluding the session, I request our session chairperson to brief about all the presentation and share his insights.
Yeah, good evening, everyone. It was a lot of technical excitement in various sessions. So just brief on each of the presentation, starting with Kandala Ramakrishnan effective high strength, high ductility 550D. A lot of challenges he has pushed and many insights people are requesting for their development of this product. So still there is a lot thing to be learned in the basically the UTS by YS ratio and guaranteeing it on test certificate. That is more important. And the second followed by changing chemistry, niobium from vanadium base and the huge saving. So it is really done in across plants. Most of the plants niobium is being used in not only in long products as well as in flat products. So it is a good saving material. People can think of cost saving, especially from sale. Sale, you have a lot of these materials where high reductions and recrystallizations are achieved. You can go for niobium based materials, and he has given good insights on it. And next by Macon, which is Mectherm, which he has given the inner deep insights of cooling systems which they use and their patented technology. So it was good how the product behaves during rolling the core and the external martensitic zones and in between band. And followed by Mr. Jude Francis' presentation on universal roll mills for rail and their defects, how their defects and how they are addressed. And one of the longest rail mills in the country, in the world, yeah, in the world. And that was good learning for most of us who had not seen rail mills. Followed by uh, uh, water water manifold modification by Abhishek on this at ISP. Here, by just changing the type of rolls, he has moved from normal rolls to high-speed rolls. There is significant improvement in consumption rate. So almost he has increased life to 3 to 4 times. So it's a good cost-saving idea. So most of the mills can think of moving high-speed rolls. But however, their maintenance part is very much important. Even small mistakes can lead to larger failures in high-speed rolls. He has given some ideas, problem solving, how he has managed temperature, cooling temperature, and water bar pressure temperatures. And then followed by enhancement of turn down inset life by Sharnesh. It's a good modification. I think the technology has to be patented. Maybe I don't know, it is jointly with Primetal or JSW. So it's a good insight how a good problem solving with a lot of development. Multiple trials have been done. PDCS has been done during this development. And then followed by development of LRPC grade, SAIL ISP. So they've given some insights. Everybody is interested in this topic. And there are some questions also. So people can discuss on the late evening. Followed by rejections, improvement, and also suggestion requirement from for Mr. Patro. SAIL ASP, they have done improvement in tong modification. They got improvement in tongs, but however, he is looking for suggestion for fuel consumption rate. It's very high, 0.5 gigacals per ton is which is high, and however, their raw materials are multiple source. So that is one which challenge which has to be addressed. So people are suggesting for old technology, maybe replacing with new technology, but still, it's the government organizations. So well done. It's a good session. So anybody has any queries? Otherwise, we can close the session. Thank you.
Thank you so much, sir, for sharing your insights. May I now request our session chairperson, Mr. MBN Raju, AVP, JSPL Angle, to kindly come forward to present momentum to all the presenters. I invite Mr. Kandala S. Ramakrishna from Tata Steel Jamshedpur. Let us clap our hands for his great presentation. I request Mr. Biswajit Punjab from SAIL ISP to please come forward. I request Mr. Lokesh Sahu from Mekon to please come forward. Let us all join our hands for the great presentations today. I request Mr. Jude Francis from SAIL BSP to please come forward. Uh, I request Mr. Abhishek Tomar from SAIL ISP to please come forward. Now I request Mr. Sharanesh from JSW Vijayanagar to please come forward. May I request Mr. BK Devangan from SAIL ISP to please come forward. May I request Mr. RL Patro and Mr. TK Paul from SAIL ASP to please come forward. Now I request Mr. Nimish Gite, HOD, LP Mills and Neotrex to kindly come forward to present memento to our session chairperson. Let us all give a round of applause to our session chairperson. Thank you so much, sir. Can we all?
दो पार्ट में ले लेते हैं हाँ हाफ ऑफ ले लेते हैं आइए प्लीज प्लीज आइए
Thank you so much, sir. I request everyone to please take your seats. There are few announcements.
एक फोटो
We would like to inform you all that as many participants have shown their interest, may I have attention, please, sir? We would like to inform you that as many participants have shown their interest in plant visits, so Hampi visit has been finally the plant visit has been scheduled based upon one's interest. And now we request everyone to have high tea outside the forum and requested to also attend the sessions at the forum hall for FP3 sessions. And the final announcement. So this marks the final program for the day. We sincerely thank all the delegates, chairpersons, presenters, and volunteers for their active participation and cooperation throughout the day. Wishing a pleasant and relaxing evening. Thank you all.